All right. 4.5. Graphs of other trig functions. Y equals tangent. Y equals tangent. Here's the domain. Range is negative infinity to positive infinity. So let's look at a t-chart for the tangent. Let's flip it over on the back. Let's go y equals tangent of theta. Let's do 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Let's just go ahead and do both our tangent and cotangents here. I flipped it over on the back of my notes. Is there a blank page in your notes?
Yeah.
You can do them on the back with the graphs. 2 pi. 0, 0 order pair, 1, 0. This is 0, 1. This is negative 1, 0. 0, negative 1. And 1, 0. And then the pi over 4s are, this is square root of 2 over 2, square root of 2 over 2. This one is negative square root of 2 over 2, square root of 2 over 2. Negative, negative. So tangent is y over x. So 0 over 1, which is what? 0. Pi over 4 is 1. Pi over 2. That's undefined. This is negative 1. 0 over negative 1 is 0. 1. Undefined. Negative 1. And 0.
So 1 is
2 pi. Now cotangent is x over y. You fill that side in. So this one is undefined. 1, 0, negative 1, undefined. 1, 0, negative 1, undefined. Go to your graphs and label them the same way we've labeled all the other ones. All right, for tangent, where are your asymptotes? Pi over 2. Where else? 3 pi over 2. Now if I went the negative, where's my first undefined going down? Negative pi over 2. And then when I rotate negative pi over 2, negative 3 pi over 2. At pi over 4, tangent is what? 1. At 3 pi over 4, where's 3 pi over 4 at? 3/4 pi, between pi over 2 and pi. It's negative 1. And then 5 pi over 4 is in between these two. And 2 pi is 0. Oh, I missed my zeros too. Okay. And then we have zeros at 0, pi, and 2 pi. Okay, I should have done my zeros first. Okay, so we did our asymptotes. Our asymptotes were at pi over 2 and 3 pi over 2. Okay. Our zeros are at 0, pi, and 2 pi. 0, pi, and 2 pi. Our ones are at pi over 4 and 5 pi over 4. 1/4 is halfway between 0 and a half. And 1 1/4 pi, that's halfway between 1 and 1 1/2. Negative 1 is at 3/4, which is halfway between pi over 2 and pi. Pi over 2 and pi. Right here. And our other is 7/4, which is halfway between here and here.
How'd you know the asymptote was on negative pi over 2 and negative 2 pi?
So if you look at our unit circle and I rotate the other way. So I rotate down here. It's my unit circle. I rotate negative pi. It's undefined down here. Okay? And then over here, it's not. So if I rotate 1.5 pi's, there's my other asymptote. Now if I rotate 1/4 of a pi, I'm going to be at -1. So I rotate a -1/4 of a pi, I'm down here. So what we have here is our tangents go like this. We approach asymptotes. So for tangent, yes,
With the negative, the second negative asymptote, wouldn't that be over negative 3 pi over 2?
yes, thank you. How did I do that? Did I say that?
You said that, but you put it on the wrong.
Okay, thank you. So what do you think is going to happen in between these two asymptotes? Same thing. We've got it here. Halfway between, we're up at 1. Halfway between, we're down at -1. So for this one, as you can see, the range is all real numbers. But the period is what? The period is pi. Okay? So for tangent and cotangent, we have a different period. And when curve sketching, and let's get cotangent graphed first. So cotangent, where's our chart? So the bottom is going to be y equals cotangent. Where's
Is there supposed to be another thing with those sides?
over here? We can if we want. It's just going to repeat. This one will go here and here. Just a repeat. Where's cotangent undefined? Well, cotangent is undefined at 0, at pi, and at 2 pi. Yeah. Where do you think the asymptotes are going to go in the negative? Well, it's going to be the negative pi and 2 pi. Does that hold true if I look at the unit circle and I rotate pi units? Is cotangent undefined up here at negative pi? Sure is. If I rotate negative 2 pi, right back here, it sure is. All right, where's our zeros for cotangent?
Pi over 2 and 3 pi over 2.
Pi over 2, 3 pi over 2. Where do I have a 1?
Pi over 4 and 5 pi over 4.
Pi over 4, 5 pi over 4, which lands halfway between pi and 3 pi. 3/2 pi. And then our negative ones here and here. If I wanted to fill these other ones in, what are they going to look like? They're going to be the same thing. Halfway between the asymptotes are my zeros, and they're going to go the opposite direction that the tangent went. Questions there. Here's what's cool about the tangent and cotangent is you just need to remember the shape. Cotangent, tangent looks like a positive x cubed, doesn't it? Cotangent then looks like a negative x cubed. So in your notes, when sketching the graph of a tangent of b minus x, it's an increasing da-da-da-da-da. Here's what the easiest part of graphing these are. Two consecutive vertical asymptotes can be found by solving these equations for the tangent. Why did they pick negative pi over 2 and pi over 2 for the tangent? Because in our graph, our original graph, our tangent, our parent graph, its original asymptotes are at negative pi over 2 and pi over 2. Could they have picked these two? Sure. They just picked these two. The other really important part, and where did I see this? Right here. The tangent function does not have an asymptote. Even though in the sine and cosine, they have asymptote, or I'm sorry, they don't have amplitude. Does cosecant and secant have amplitude?
Yes. No.
Because they go up forever. Amplitude is how tall they are. Amplitude is how tall they are. They go on forever, so they don't have amplitude. The only trig function that's amplitude is sine and cosine. Okay? I guarantee you there's going to be a question on your test that says y equals 5 cotangent of theta. State the amplitude. What are you going to say for the amplitude? None. It has none. I guarantee you over half of you will tell me it's 5 or whatever number's in front of it. Guarantee. Doesn't have amplitude. Be careful. When sketching, the cotangent, two consecutive asymptotes can be found by setting them equal to 0 and pi. X-intercepts are located at the midpoints between consecutive vertical asymptotes. I didn't highlight that on the other one. Same is true for tangent. All right, so let's look at graphing 2 here and then. So, negative tangent of 2x. First thing we're going to find is the asymptotes. It's tangent. I don't think I said this, but we can find the period. The period is found by taking pi and dividing that by b. Cosecant, secant, sine, cosine, to find their period, it's 2 pi over b But because tangent and cotangent have a different period, it's pi over b. What's b here? 2. So the period is going to be pi over 2. To find asymptotes, we set 2x equal to what? Or 2x equal to what? We're doing tangent. Tangent, we set them equal to negative pi over 2 and pi over 2. Divide by 2 to solve for x. So this is negative pi over 4. This is pi over 4. Divided by 2 is the same as multiplying by what? 1/2. So pi over 2 times 1 over 2 is pi over 4. So I have an asymptote at pi over 4 and an asymptote at negative pi over 4. The 0 is found halfway between them. Is this a period of a half a pi? Yeah. A fourth here and a fourth here makes a half. Now, tangent goes what direction? Tangent goes this way. Except this has a negative in front, so what's that do to the direction? It flips it, so this one's going to go like this because of that negative. Now what if I ask you for the next positive asymptote, what will it be? Next positive asymptote. What was it? 3 pi over 4. It's what? Pi over 4 plus pi over 2. So 1/2 plus 1/4. Questions on that one? All right, one more. Cotangent. Let's find the period first. Period is found by taking pi, dividing it by b. What's our b value here? What is it? It's 1/4. It's 1x over 4, so it's 1/4. So in this case, we get a period of what? 4 pi. Asymptotes are found by taking x over 4 and setting it equal to what?
Negative pi over 2 and plus, oh, stiff negative
Cotangent is
0,
0 and pi. So 0 and pi. So our first asymptote is going to be at 0. Our second asymptote is going to be at 4 pi. Does that give us a period of 4 pi there, guys? Pretty doggone cool. So if 0 is our first asymptote, 4 pi is our second asymptote, where's our third one going to be?
In the middle.
A pi. Asymptotes are between our two periods. So our period's 4 pi. So there's 4 pi. Our next period will be another 4 pi. And then our zeros are halfway between. So at 2 pi and 6 pi. And then what direction does cotangent go? It goes like this.